Hello, a warm welcome to all. Today we are going to talk about another important topic, which is pH and its importance in medicine. My name is Dr. Anush Sharma. Now, I have made two classes on acids and bases and also indicators in pH, and which in these two classes I've talked something about pH. So viewers can get back to my classes by going to my channel, and you can have a better idea about the talks that I've made. So in short, I'm going to say something which can help to understand the concepts of pH, which I have talked extensively in my last class. So what does pH mean? pH measures what? Strengths of the hydrogen ion concentration. So it only measures the strengths of the hydrogen ion concentration. And how we find a pH of solution? pH solution is found by is equal to minus log of the hydrogen ion concentration. So what does it means is that when the hydrogen ion concentration increases, the pH decreases, and this solution becomes an acidic solution. And when the hydrogen ion concentration decreases, the pH increases, and this solution becomes the basic solution. Now today's talk is what is the importance of pH in medical science. So let's get into these concepts right now. So for this, I'm going to find out a scenario. For example, in the human body, suppose we take a syringe and we draw a blood sample in this way. So and we then analyze this blood sample for the substance and electrolytes. So what we will get? So we will get the following values when draw the blood sample. Number one is the sodium level. The sodium level is 135 milliequivalents per liter or 135 millimoles per liter. The range is around 135 to 145 millimoles per liter. Now if you want to convert this 135 milliequivalents to milligram, what you have to do is that this sodium 135 we multiply with the atomic mass, which is 23, and is divided by the valency. So this comes to around 135 times 23 divided by 1, it comes to 3105 milligrams per liter. Similarly, when you look at the normal potassium in a blood, it's around 3.5 to 5.5 milliequivalents or millimoles per liter. And again, if you want to get to something on milligram, what we have to do is a 3.5 we multiply with the atomic weight, which is around 39, and divide by the valencies, and it comes around to 136.5 milligram per liter. So what is the calcium level? 8.5 to 10.5 milligram per deciliter. What is the normal magnesium level in blood? Is 1.7 to 2.2 milligrams per liter. So after drawing the blood sample, if you show this report to a healthcare professional or doctor, you'll find the following reports. The sodium is 135 normally, potassium is 4 milliequivalents per liter, the calcium is 8.5 milligrams per deciliter, magnesium is 2 milliequivalents per liter, and the sugar, the random blood sugar, is 100 milligrams per deciliter. So these are normal blood reports that we usually get in a normal individual. But what about the hydrogen ion concentration? Hydrogen ion concentration, we don't know. So for this reason, to know about the hydrogen ion concentration, the hydrogen ion concentration is very, very small in blood. You will be surprised to see that it is around, hydrogen ion concentration is equal to 0.000000007 zeros followed by 4 equivalent per liter. That is, it comes to about 4 into 10 to the power minus 8 or 40 nano equivalent per liter. So low in the blood compared to sodium and potassium. We say sodium is 135, potassium is 3.5. The hydrogen concentration is 4 into 10 to the power minus 6, very much small in blood. What would happen if the hydrogen concentration goes to a single digit figures like 4? Unfortunately, we will not be surviving in this planet. We will always die in this planet. So it's so important that the hydrogen concentration in the blood is very small. So coming back to the hydrogen concentration in our normal body system is around 0.00000004 equivalents per liter. But if you say this report to a normal person or a doctor, he will look very confused, because you cannot express this hydrogen in this value of 0.000. It will be a lot of confusion and a weird feeling. To solve this problem, there were some smart people who devised a very important formula. One of these is a smart people like Danish chemist Søren Sørensen in 1909. So he is a pioneer of the pH scale. So what he did was that, and you see hydrogen ion concentration is 0.000074 equivalents per liter. He applied log on both sides of this equation. So when he applied log, hydrogen ion is equal to log on this side. Both sides he applied log. So what he found was that when he applied log, if you take in the calculator also, he found that the log of hydrogen ion is equal to negative of 7.4. So when you apply this log, you find that it's negative. But still, although it makes some sense compared to 0.0004, but still the negative part, it also gives us to some sort of confusion. So you see, so what it again did was he applied negative on both sides. He applied negative log of hydrogen ion is equal to negative of 7.4. Negative and negative in mathematics comes to positive 7.4. In reality, negative and negative is not positive. So negative and negative is always a dangerous thing. So coming back to situation, so then again we find that minus log of hydrogen ion concentration is 7.4. So this is again a little bit of a dicey situation. So what it again made was he put the substitute is minus negative log to power of hydrogen ion, and this comes to 7.4. Now he wants to remove the hydrogen ion concentration, so he then replace the power of hydrogen ion to pH. So pH is equal to 7. This is how we calculate the pH in a normal solution. So as you see, what Sørensen devised a pH scale. The pH scale, as we already talked in the earlier lectures also, it is from 7 to 0 it becomes acidic, and from 7 to 14 it becomes alkaline, and 7 is a neutral pH of the solution. And in common day-to-day practice or life, we find that a lot of substance like gastric acid, lemon juice, apple juice, so as we move from 7 to 0, the pH ultimately decreases, and as we move from 7 to 13, the pH ultimately increases. Now let us take an example. How we calculate the pH calculate the hydrogen ion concentration if suppose we take a lemon juice pH of 2. So what we do is that, as you know, pH is equal to negative of log of 10 base of hydrogen ion. So we put pH 2 here, and we take a negative of log of hydrogen ion, and we calculate. We find that hydrogen ion is equal to 1 into 10 to the power minus 2, which is called 0.01 milliequivalents per liter or equivalents per liter. So this is how we calculate pH if we have the pH of how we calculate the hydrogen ion concentration if we know the pH of the solution. So based on this formula, we find that when a pH is 7, the hydrogen ion concentration is 1 into 10 to the power minus 7, 0.0000 7 zeros. For a pH of 6, it is around 1 into 10 to the power minus 6, and for a pH of 5 is 1 into 10 to the power minus 5. A pH of 4, 1 to 10 to the power minus 4. That means you remove another 0, and pH of 3, 1 to 10 to the power minus 3, you remove another 0 from this 4, 2, 1 to 10 to the power minus 2, 1 10 to the power minus 1, and 0, 1. So what does it mean? If you look closely in this chart, is that as the pH decreases from 7 to 0, the hydrogen concentration increases. As you see, the hydrogen concentration of pH of 1 is much more than the pH of 3. So this is a very important concept to understand, that when you suppose the hydrogen ion concentration of 10 to the power minus 7, and if you see the concentration 10 to the power minus 6, the pH of 6 has got much more hydrogen ion concentration compared to pH of 7. So we look, pH of 7 we got a hydrogen ion concentration of 1 to 10 to the power minus 7, and pH of 6 we have got the hydrogen concentration of 1 to 10 to the power minus 6. So if you want to get from 10 to the power minus 7 to 10 to the power minus 6, what you do? We remove 1 0. How we remove 1 0? We multiply by 10. That means that when the pH decreases from 7 to 6, the hydrogen ion concentration increases 10 times. This is a very important concept to know, that it increases by 10 times. So this chart depicts the problem. When you have a pH 7, suppose we have a pH of 7 and the pH decreases to 6, the hydrogen concentration increases 10 times. When the pH is 7 and decreases by 2 units, 5, the hydrogen concentration increases by 100 times. And we have a pH of 7 and it decreases 4, it increases by 1000 times. Just imagine, just one difference 10 times, and two difference it becomes 1000 times. So it's like a very simple situation. Suppose you're going from point A by a car and you're going to point B, and the distance covered is just 1 meter, but how much petrol we have burned? 10 times petrol. Or suppose you're traveling, you have to pay 10 times the money. So that's the importance of the pH. A small change of pH manifests into a manifold increases in hydrogen ion concentration. So a 1 unit change of pH increases hydrogen concentration by 10 times. It increases by 10 times. So what does it mean? That is, when the hydrogen ion increases, there is a decrease in pH, as we all know. This leads to a condition of acidosis, and this acidosis causes impairment of the vital enzyme system of the body. We'll talk later in subsequent classes. So in our body, a lot of enzymes work at a definite pH. For example, gastric juice functions optimally at a different pH. Pancreatic juice functions better different in a very particular pH. So when this hydrogen ion concentration changes, these enzymes gets deactivated, and this may lead to cell damage and death. You may be surprised to say that our normal body pH is around 7.35 to just 7.45, just 0.10 difference. It's not 7 to 8 or 6 to 7, just point. We maintain it in a very small range, because we know that a small change of pH will have a dramatic effect on hydrogen ion concentration. So this is brought about by excellent regulatory system in the body, brought about by blood buffers, respiratory and renal system, which we'll again talk in the subsequent classes. So the purpose of this class is to make you understand that what the importance of pH and the hydrogen ion concentration in our body, how a small pH change makes a dramatic change in the hydrogen concentration, which may affect a lot of functions in the body. And that is why it's very important that our body systems regulate this pH. And this is important that we all physicians should understand the importance of pH with regard to medicine. So I hope it makes sense to this lecture. I hope I was able to convey the important message of pH and its role in medicine. Please send your comments, like and share with your friends and colleagues, and please subscribe to the channel, and thank you so much there.